Okay, we have two more. Okay, the first one, optic related, basically is use the principle of optic operations. So we can measure the images based on the reflection of the optic signal. And also we can use the reflections to measure the depth, similar to the distance of the sensor. Okay. The last one is biosignal related. That means we can measure the bio or vital signals of the human being. For example, we can measure the temperature, and also we can measure the heart rate sensors. These are two examples we illustrated here. Okay, if you look at the last one, heart rate sensors, the sensors operation in this way. It's quite simple. We quickly look at the principle here. Okay, you see we have a so-called light source. In general, it's infrared. Okay, high frequency light source emitted through or to the fingers or whatever you touched. Then, based on the heart rates, you see the flooding in your fingers. Okay, so we can receive different signals. Okay, so we have a light source. Another one we have a light detectors. Based on the strength, so we can and the frequencies we count of the devices, so we can get the heart rates. Okay, that's why whenever we measure the heart rates, we have touch on something else. Okay, this is because the operation is based on this. Okay, but we have one question is, if it depends on one single individual, the sensors to operate, probably not enough for practical. It means in most cases, we like to measure lots of signals, different informations simultaneously. Okay, it will be called for smart, integrated, or even intelligent sensors. Okay, so here we have different kind of variations for individual sensors. The first one we call integrated or hybrid. Integrate means we have different kind of sensors integrated together into a small pieces. That's why we can put them into a small devices like a cellular phone. Okay, hybrid means we can combine those different functionality sensors together. Signals can be measured on its original form. That means if we have two sensors, one measure the biosignal, one measure the environment signal like a CO2, they will not be messed up together. This is what we mean the smart sensors, but they can combine into one body, one sensor body. Okay, the second one is so-called sensor systems. We take auto parking sensor system as an example. You can see to the right, the figures we have auto parking tells you how to park your cars automatically. It will give you some correct informations or even the visions for the drivers to know how to park, or for the machines for the cars automatically parks without the operation of the drivers. So we need a lot of sensors. We need a camera to take the image to do the analysis. We need the infrared distance sensors to know how close the car is to maybe the wall or somewhere, or the car nearby. Okay, and so forth. So we have lots of sensors in case we are going to pump into the nearby cars. We need some buzzers, okay, to alarm to notify the drivers. Okay, so this is lots of sensors integrate together, but they are not put into one devices. They operate individually, but they connected together through a central control unit. This is what we mean the sensor systems. Another one is called a sensor array. Basically, sensor array is composed of lots of sensors. For example, we have a pressure sensor array. Okay, this is one of the figures. Okay, we see lots of dots we form a plane. Okay, basically a black dot represents a pressure sensor itself. Now we have this connected together, transmit the signals back to the circuitries for processing. Okay, we can use pressure sensors, make it like a blanket, put it on the bed, so we can know the movement, know the sleep conditions of the patients or anybody else. Okay, this is pressure sensors. Okay, we'll look at the sensors as we say, we combine the sensors app and then the up layer, the application together. Okay, so one, we can explain more about the operation of sensor, and also we can look at the application of the sensors, how the system composed. Okay, so we will not see the woods without the trees. Okay, so you see this is the example one. We look at some variable devices. Okay, so to the left of the slides, you see lots of variable sensors. Here I have one here. I can take it off. Okay, for demonstrations. This is the wearable equal watch. It's okay. Basically, it's a wrist. Okay, so you can measure the blood pressure, and also you can measure the heartbeat rate. Okay, this is the wearable devices. One of the example. Okay, the example we show on the slide here is the vest. Okay, so in the middle, upper figure represents a vest. It looks like a normal vest, but look at the insides. We have lots of electricity, electronic circuit sensors put them together to measure your biosignals. This is the vest. Basically, the wearable vest has been commercialized. You can buy it from the markets. It costs maybe 4,000 or 5,000 NT dollars. Okay. Okay. To the right, we show the processing flow of the whole wearable devices. So we have lots of sensors equipped. We have a gyrometer, accelerometer, magnetometer. Okay, so we can measure the magnetic field. We can measure how fast the guy is moving, and we can also see if the guys keep balance or not. Okay, so if we have these sensing signals coming into together, we integrate them together. We need to process it. Okay, we have a microcontroller, a small chip to process application signals and pack into a specific format for communication, for transmitting back to the application layer for processing. Okay, so we need the communication interface. It depends on what kind of communication technology you applied. For example, you may apply the public cellular phone like 3G or 4G, and also you can use a Wi-Fi and so forth. Okay, that's why we have a communication interface here. Okay, down below there will be a propagation of signals back to the internet, back to the applications and so forth. This is the first one. We see the wearable devices. The second one, we can look at the application of telemedicine. Okay, so here is an example. From this example, we will see the expansion of the sensor and also the IoT. Okay, you see here we have a kids play somewhere. Okay, so we have some sensors to measure bioinformation. It's probably not a good example for this application. Basically, telemedicine can be applied to chronic disease patients. It will be better, or to the elders. Okay, and the last one we apply to the kids. Okay, but anyway, this is an example. Basically, we have sensors measure temperature, blood pressure, blood sugar, heart rates, and so forth together. Then, based on these biosignals, then we can analyze the health conditions of the guys being monitored. Okay, so we see, since we have a lot of sensors, or maybe we have also the environmental information to be collected. So you see the green dot all represents the different kind of sensors. These sensors has to be propagated to the back ends for processing, since the back end will be collect data, analyze data, and generate useful information, okay, for human being. Okay, so you look at lots of sensors has to be connected together. So this sensors has to be possess another capability, which is play the role of data forwarding. So each sensor not only propagates the data it generated itself, it has also to process, to forward the data from the nodes, the sensor node nearby. Okay, so here is the example. We have see the dotted line represents the propagation of the data from different sensors. All the data has to go to a sink or the gateways to collect the data, then through internet send back to the backend system for post processing. Okay, so if we realize there are some dangerous situation happened, then we can send the help, send the risk immediately. This is the second example of telemedicine.